Hello dear students, let's talk today about sequence and series. According to our syllabus, we have to study two different type of series or progression. The first one is arithmetic and the second one is geometric. Today let's talk about arithmetic. At first, I want to give some example here, like suppose 1, 3, 5, 7, 9. Okay, and these numbers are separated by comma. Okay, here in this example, we can get any successive terms by adding a constant number to the previous term. Yeah, as for example, we have here 3. We have got this 3 by adding 2 from the previous term 1. 1 plus 2 we have got 3. In the same way, this 5 we have obtained by adding 2 with its previous term. In the same way, we have obtained this 7 by adding 2 to the previous term. Means in each and every new successive term, we obtained by adding a constant number from the previous term. So it's a sequence. Okay. At first, to know about the arithmetic progression or arithmetic series, or better say arithmetic sequence, we must know what is sequence. So we are talking here about sequence. Clear? Now let's take another one example. Suppose B, here 2, 4, 6, 8, okay, 10. Here also we obtain a new successive term by adding a constant term to its previous term. Yeah, we obtain 10 by adding 2 on 8. We obtain 8 by adding 2 on 6. Means here in each gap interval, yeah, the term is 2. With adding 2 to its previous term, we are getting the new term. Means here also it's a sequence. That means to be a sequence, a set of numbers which are arranged must follow a certain rule. If they are following a certain rule and we can easily predict the new successive term of a certain term, then we can call it as a sequence. Let's take another one example. Suppose C number. Here we can take as 1, 4, 9, 16 and above. It's also a sequence. It's a sequence of, yes, see, 1, it's a square of 1. 4, it's a square of 2. 9, it's a square of 3. 16 is square of 4, and so on. That means it is a sequence of square number. Yeah, so we can call it as also a sequence because it also follow a certain definite rule. That means the collection of number in which each number which are organized follow a certain rule. It's a sequence. And these each and every number which appear in order, we call them as a terms. Okay, terms. Terms means the number which we have in our sequence, we call them as a terms. Here first term, second term, third term, fourth term and fifth term. That means here also first term, second term, third term, fourth term and fifth term. These numbers are called terms. Means number in a sequence is called term. Okay, that means here we have 4 terms, here we have 5 terms, here we have 1 2 3 4 5 and so on. Means we are not defined, we are not clear how many terms do we have. Okay, now as we discussed just now, according to the number of terms, we have 2 different types of sequence. The first is finite sequence and the second one is infinite sequence. Finite sequence are those sequences in which the number of terms or number are defined, okay, are constant, are fixed. It's called a finite sequence. And those sequences in which the number of terms are not fixed, means not defined, not clear, we call it as a infinite sequence. If we talk about the above example B is a finite sequence and example A and C are infinite sequence. Clear? Let's take one example. 2 4 6 8 10 12 is a finite sequence because here number of terms n equals to 1 2 3 4 5 6, means we have 6 numbers, 6 terms we have. Here let's give one example for this infinite sequence. Okay, 2 4 6 8 10 and so on. Means here how many numbers do we have, we are not clear. Means how many terms we have, we are not clear. So this type of example is called as a infinite sequence. It follows a certain rule. Yeah, here in each interval we have 2. That means for both here or there, okay, 4 minus 2 we have got 2. Similarly 6 minus 4 we have got 2. 8 minus 6 we have got 2. 10 minus 8 we have got 2. Everywhere same, yeah, means constant. So that means each new successive term we obtain by adding a constant number 2 on its previous term. In this way we are getting any successive number. So we call it as a sequence. And here the number of terms are not fixed, not defined, so it's became a infinite sequence. And here number of terms are defined, we are clear how many terms, we can easily say here, so it's a finite sequence. Now dear students, after getting ideas on this sequence, let's take ideas on series. The same numbers which we found in an organized form in a sequence, if we combine or collect them by plus or minus sign, then we call it as a series. Okay, when the numbers or terms of the sequence are connected by sign plus or minus, we call it as a series. Now see, same example I take from here and I will express here. 1 plus 3 plus 5 plus 7 plus 9 plus ... Yeah, then this type of arrangement of the terms with plus sign, then we call it as a series. Similarly, for this one we can also do like this. Here for this one, 2 plus 4 plus 6 plus 8 plus 10. Now this one became the example of series. Means we are collecting or we are joining these two terms with plus sign, these two terms with plus sign. So it became series. That means the number will be joined or collected by either plus sign or minus sign, then we call it as a series. Just this is the difference between sequence and series. In sequence they are separated by comma. In series they are connected by plus or minus sign. Okay, let's take on progression. progression. Okay, progression, a sequence or series. Okay, we are talking on sequence and series. A sequence or series is said to be a progression if the difference or ratio, okay, if the difference or ratio between two successive terms is constant throughout the whole sequence or series. Clear? Okay, with example let's try to make it more clear. Our first example, 1 3 5 7 9 and so on. Okay, it's a sequence because it is following a certain rule. If we add 2, yes, to first term means preceding term, we are getting the succeeding term. In the same way we are getting. Let's check that as well. Here one thing we need to be clear, that is this first term we call it as a T1 and it as a T2, this one as a T3, this one as a T4, this one as a T5 and so on. That means here the difference of first these two terms, see, 3 minus 1, okay, we'll get 2. Similarly, if we take the difference of these two terms, 5 minus 3, we also get 2. Again, let's see the difference of these two terms. Yeah, 7 minus 5 equals to also 2. And here difference of these two terms, 9 minus 7 also 2. That means here constant difference. Yes, here whole what we have got a constant difference, where we have discussed, okay, throughout the whole term if the difference or ratio between the two successive terms, okay, between the successive terms is constant, either ratio or difference, then it will be a progression. Means constant difference is equals to 2. So this example is in progression. So we can write therefore 1 3 5 7 9 and so on, if it goes on increasing, are in progression. And later on we'll discuss if the constant, we have the difference is constant, we call it as a common difference, and it's a arithmetic progression, okay, AP. We'll talk later on. And the same way, let's take an example. This is the example first. Let's take the second example. Okay, 2, 4, 8, 16 and so on. Okay, we have another sequence. Let's try to find the difference first. Will the difference comes constant or not? Here this T2 means 4 minus T1. We have to T3 minus T2, 8 minus 4, 16 minus 8. See, here we don't have the ratio constant. Ratio is not constant. So this sequence is not arithmetic sequence. Okay, to be arithmetic sequence, here, sorry, I have written ratio, sorry, it's a difference. Difference is not constant. Okay, the difference is different here. We don't have the constant. So what happened? It's not a arithmetic progression. Okay, here let's check ratio, whether the ratio is same or not. Okay, similarly, same way we do for first, we have to do like this. T2 minus T1. Okay, here 4 divided by 2 means T2 by T1 equals to 2. Again T3 by T2, 8 by 4. Here also we are getting 4 times 2, 8. And here 16 divided by 8. Here also we are getting 2. See, the same thing like that. That is, we have constant what? Ratio. If the ratio is constant, we call it as a common ratio. And if the ratio is common, then such type of sequence or series, we call it as a geometric progression. Okay, now we can write therefore 2, 4, 8, 16 and so on are in progression. Types of progression. We have got two different types of progression. The first one, arithmetic progression, and the second one we have discussed, geometric progression. Arithmetic progression represented as AP and geometric progression represented as GP. Here we have defined by the help of common ratio, and in arithmetic by common difference. Common difference represented by D and common ratio represented by R. Now the definition which we have defined is similar here as well, because there we have talked about the constant, different and ratio. Here also same. A sequence is said to be arithmetic progression if the difference between two terms is constant throughout the whole sequence, okay, or series. For example, let's take 1, 5, 9, 13 and so on. Then in this case, to get a difference, okay, we always subtract second term by first term, third term by second term, means succeeding minus preceding, okay. 5 minus 1, 9 minus 5, 13 minus 9 in this way. Here we have got 4, here also we have got 4, and here also we have got 4. So here constant became 4, so we call it as a arithmetic progression. And students, here this 1, 5, 9, 13 is a sequence where we call it as a first term T1, or by A is a second term T2, is a third term T3, is a fourth term T4, and so on. So we can say Tn, n term. Okay, now see here, first term is represented by T1. Clear? Or we can see it as a A. And the second term T2. How we calculated T2? This 1 plus 4. We have got 5, yeah? 1 plus 4 means A plus D. We have got 5 means T2. So I write here A plus D. Clear? Or I also can say that T1 plus D. And again this T2. After this T2, let's go for T3. T3 means again 4 has been added, yeah? So that T3. For T3, I can say A plus D plus D. A plus this D plus this one D. We have got T3 means here directly I can say A plus 2D. Similarly for T4, A plus D, here D plus D plus again D. We can get T4. A plus D plus D plus D means A plus 3D. Clear? Okay, here see once again this T1 means, okay, this T1 means A plus 0 times D. Clear? 0 times D means 0 times D is 0, 0 plus A is A. No change, yeah? Here A plus, here this is 1D. 1D means how can I do here? 2 minus 1D. Here A plus 0D means A plus 1 minus 1D. 1 minus 1 is 0. This one I can write like this also. I am doing everywhere this minus 1, so that here A plus 2D means A plus 3 minus 1D. See what I am representing? Here is 1, so 1 minus. Here is 2, so 2 minus 1, okay? Here is 3, so 3 minus 1. Similarly, here is 4, so that A plus 3 means 4 is here, 4 minus 1 D. Yeah, here is 4 term, so that 4 minus 1. If the same thing we go on, one time Tn we reach, yeah, process is same. Then here what happens? A plus, yeah, A plus bracket, here is n, so that n minus 1 D. Clear? That means here is n, so that here is also n. This is the formula of nth term. Okay, nth term means Tn is equals to A plus n minus 1 D. This is our formula. We have to remember this formula where A is the first term. Okay, A is the first term. Okay, I'll write here A is the first term, and this n number of terms, this D common difference, and this Tn means nth term, and this one generalization, we call it as a general term. I write here general term or generalization or nth term of arithmetic progression. Okay, here this we call it as a first term, this we call it as a second term, this we call it as a third term, and this one as a fourth term. In this way we generalized for the n term. This will be our formula. Okay, thanks for watching. Dear students, please don't forget to like, share and subscribe our channel. In our next class we'll talk on different problems. We'll try to solve different problems related to arithmetic progression. Thank you once again.